What is polarization? Why only transverse waves can be polarized? What do we mean by a plane polarized wave? How does the picture in front of you relate to that? Take extra care with this definition. Let's assume we go down saying this is the plane of polarization. In other words, the oscillations of the electric field. What can you say about these oscillations? They are, you're trying to complete the sentence, but be extra careful with the words you use. How does the direction of travel of the wave relate to the polarization plane, to the polarization direction? So what can you say about the plane of polarization and the direction of travel of the wave? What can you say about the direction of polarization in plane polarized light and the direction of travel of the wave? What happens when unpolarized light passes through a Polaroid? So we will add a Polaroid. Clearly, the intensity decreases. What can you say about the new value of the intensity of the light that goes through the Polaroid? What happens as I rotate the Polaroid? Is there a change in the intensity? Now let's line it up so the zero value is vertical. Let's introduce a second Polaroid, initially aligned with the first. So the axial polarization is the same. Look carefully at the light that goes through. Now I'm going to rotate one of the Polaroids gradually until the two Polaroids are at 90 degrees to each other. There we go. Can you describe what happens? Can you explain what happens? What will happen if I continue and rotate by another 90 degrees? So we continue. So now we're on 180. And if I continue further, 270, and finally back to the two Polaroids being aligned. Can you explain the results? Can you draw a graph showing the variation in intensity between 0, 90, 90, 120, 180, 180, 270, 270, 360 degrees? Here we have a laser. And there you can see the spot. How can we show that the light from this laser is plane polarized? What does that mean? Let's add a Polaroid between the screen and the laser light. Now, there you go. And this is what we see. Clearly, if it's polarized, the plane of polarization of the Polaroid and the laser are now lined up. What will happen if this is plane polarized light as I rotate the Polaroid? So I rotate the Polaroid, look carefully at the screen, and when I rotate by 90 degrees, you can see virtually nothing. If I continue rotating, it appears. When am I going to have the maximum intensity in the spot of the laser light? And if I continue further, as expected, continue further, come back, until I reach again back to the two planes being aligned at 0. Let's look at microwaves, their production and detection. Let's look carefully at the microwave transmitter. Have a look inside. Look carefully at the wire that basically is going to be our transmitter. Now, let's look at our receiver. And let's turn on the equipment. So, we can definitely detect the microwaves. What happens if we rotate the receiver? Listen to the signal. Although we're not changing any distances, the signal goes down to virtually nothing. What does that tell us about the actual microwaves? Make sure you use the correct physics terminology. Now let's put back the receiver. So again we go to a maximum. Now let's introduce a metal grill between the transmitter and the receiver. So again, with the metal grill horizontal, the signal goes to 0. Let's rotate the metal grill. What do you expect to happen? What actually happens? So as the grill is rotated fully 90 degrees, we seem to recover the signal. What does that tell us about the nature of the microwaves produced by this transmitter? Is there an equivalent effect with light? Light and microwaves are both electromagnetic waves. What type of waves are these? Can we observe the same phenomenon with sound? In this demonstration, we have a plastic triangle sandwiched between two Polaroids. We start with the Polaroids having their axis of polarization parallel. And we can see clearly some color. Let's rotate one of the Polaroids and see what happens. Look carefully. Perfect. What do the colors indicate? What phenomenon can be used to explain the observation? What do we actually observe? Can you describe what you have seen? Here we have a normal computer with an LCD display, and we have added in front of the computer screen some plastic objects, a triangle and a petri dish. I'm going to add now a Polaroid between the camera and the computer. What do we expect to see? Can we explain it? There you go. How do you explain the formation of colors? How do you explain the fact that the screen appears dark? What will happen if I rotate the Polaroid? I'm rotating now the Polaroid. Look carefully. What does that tell us about the light that comes from the computer screen? How do we get colors inside the plastic objects?